Test for the convergence 2 by 1 square into x plus 3 square by 2 cube into x square plus so on and plus 1 power n by n power n plus 1 into x power n plus so on. So you take un is equal to n plus 1 power n into x power n by n power n plus 1. First you take nth term of this series. Then if you have the nth term has a powers of n, then use Cauchy's nth root test. So Cauchy's nth root test is limit un power 1 by n as n tends to infinite is L. If L is less than 1, convergent, and L is greater than 1, it is divergent. If L is equal to 1, test failed. So we apply Cauchy's nth root test. Limit un whole power 1 by n as n tends to infinite. Here un is n plus 1 power n into x power n by n power n plus 1 whole power 1 by n. So 1 by n is applied for both the terms. Then we have n plus 1, n power 1 by n, I mean n into 1 by n, x power n into 1 by n, n power n plus 1 by n. We have this. N power 1 plus 1 by n can be written as n into n power 1 by n. Now n plus 1 by n can be written as 1 plus 1 by n. N by n 1 plus 1 by n by n power 1 by n into x. X taken out. Now as n tends to infinite, 1 by n tends to 0, and also we note that n power 1 by n as n tends to infinity is 1. Now put these values. X. So final value is x. By Cauchy's root test, sigma un is convergent if x less than 1, divergent if x greater than 1. Cauchy's root test, sigma un is convergent if x less than 1, divergent if x greater than 1. Test fails if x equal to 1. Now, if x equal to 1, then un is equal to n plus 1 power n by n power n plus 1. Now simplify, 1 by n taken out, and n plus 1 power n by n power n can be written as 1 plus 1 by n whole power n. Now choose Vn as 1 by x. You have to choose Vn either auxiliary series or geometry series. So here Vn is 1 by n. Now un by Vn as n tends to infinite, 1 by n, 1 by n, 1 by n got cancelled. We have 1 plus 1 by n whole power n. Limit n tends to infinite 1 plus 1 by n whole power n is e, which is not equal to 0. By p series, sigma vn is equal to sigma 1 by n is divergent since p is equal to 1. By comparison test, sigma un is also divergent. Therefore, the given series converges if x less than 1, diverges if x greater than or equal to 1. Now test for the convergence. 1 by 6 minus 2 by 11 plus 3 by 16 minus 4 by 21 plus so on. So we observed that this is an alternating series. So you write in summation notation as sigma n is running from to infinite minus 1 whole power n minus 1 into n by 5 n plus 1. Because 1, 2, 3, 4, so on, it means its nth term is n, because those are in arithmetic progression. And also 6, 11, 16, 21, those are in arithmetic progression whose nth term is 5n plus 1. Okay. Now take un as n by 5n plus 1. Clearly un greater than 0 and un greater than un plus 1 for all n belongs to capital N. Now calculate second condition, limit un as n tends to infinite. Here un is n by 5 n plus 1. So n take common in the denominator. Cancelling n both numerator and denominator. We have 1 by 5 which is not equal to 0. So second condition of Leibniz test fails. Therefore it is divergent. Since second condition of Leibniz test is not satisfied, therefore the given series is not convergent, which is known as oscillatory series. Now, for what value of x given series convergent? X minus x square by root 2 plus x cube by root 3 minus x power 4 by root 4 plus so on. This is an alternating series and which can be written as sigma n is running from 1 to infinite minus 1 whole power n minus 1 into x square so on we write as nth term is x power n, and root 1 root 2 root 3 root 4 so on can be written as its nth term as root n. So here un is equal to here un is equal to x power n by root n. No, you take un as total. Okay. So un take as total of this. Now take modulus of un. It is modulus of minus 1 whole power n minus 1 into x power n by root n. So modulus it gives positive. Minus 1 whole power n minus 1 is 1 and modulus of x power n can be written as mod x power n by root n. Okay. Now apply D'Alembert's ratio test. Modulus un plus 1 by mod un as n tends to infinite is limit n tends to infinite mod x power n plus 1 by root n plus 1 by mod x power n by root n. And simplify, you get this mod x into limit n root n by root n into root 1 plus 1 by n mod x limit n tends to 1 by root 1 plus 1 by n as n tends to infinite 1 by n tends to 0. So finally we have mod x. By D'Alembert's ratio test, the series converges if x less than 1 and diverges mod x greater than 1, and the test fail when mod x equal to 1. If mod x equal to 1 means x equal to 1 or plus, my main mod x equal to 1 means x equal to 1 or minus 1. So if x equal to 1, then 1 minus 1 by root 2 plus 1 by root 3 minus 1. This is an alternating series which is convergent by Leibniz test. Right. And other case is if x equal to minus 1, then we have minus of 1 plus 1 by root 2 plus 1 by root 3 plus 1 by root 4 plus so on. So this can be written as sigma n is running from 1 to infinite 1 by root n whose coefficient is minus, which is divergent by p series test because 1 by n power of, according to the p series, sigma 1 by n power p is convergent if p greater than 1 and it is divergent when p less than 1. So p is equal to half which is less than 1. So it is divergent. Therefore, the given series converges if minus 1 less than x less than or equal to 1. This is the interval of convergence. Now test for the convergence sigma minus 1 whole power n minus 1 into 1 by root n into n plus 1 into n plus 2. So we observed that this is an alternating series. Now take nth term as 1 by root n into n plus 1 into n plus 2. Clearly un greater than 0 and un greater than un plus 1 for n belongs to n. So first condition is over. And now take second condition. Limit n tends to infinite. Limit un as n tends to infinite. So limit 1 by root n into n plus 1 and n plus 2 as n tends to infinite is equal to 0. So first and second conditions of Leibniz test satisfied. Therefore, by Leibniz test, the given series is convergent. Prove that the series sin x by 1 cube minus sin 2x by 2 cube plus sin 3x by 3 cube so on converges absolutely. To proving converges absolutely, first you write nth term. So the sigma notation is sigma n is equal to 1 to infinity un as sigma n is equal to 1 to n minus 1 whole power n minus 1 sin nx by n cube. Okay. This is an alternate series. We know that. Now take un as total of this. Okay. Now take modulus. Modulus of sin nx by n cube. And this is gives positiveness. And we know that mod sin x which is less than or equal to 1. So mod sin nx by n cube can be written as less than or equal to 1 by n cube. Since mod sin nx less than or equal to 1. By P series sigma 1 by n cube converges since P is equal to 3 greater than 1. According to the comparison test, sigma mod un converges. Therefore, the given series converges absolutely. You check comparison test. Yes, this is the property. sigma un and sigma vn are positive term series such that un less than or equal to c into vn for all n belongs to n for some positive constancy, then sigma un is convergent if sigma vn is convergent. We use this property. Sigma vn is convergent, sigma un is convergent. Thank you very much.